Good morning, everyone, and welcome to our new ERCI webinar on innovative methods for monitoring rail infrastructure. The agenda follows the usual agenda we used for the ERCI webinars: 2 speakers, questions and answers, and news from the ERCI network. Shortly to introduce ERCI and to introduce myself, my name is Senceive from Berlin, Partner for Business and Technology, representing cluster transport, mobility and logistics in the German capital region. We are one of 18 nationally, regionally focused railway or mobility logistics clusters, which are covering 17 European countries as a whole. That is ERCI, is founded in 2010 and being a legal entity based in Brussels since 2022. We are representing in total over 3,600 enterprises, and the majority of them are small, medium-sized enterprises and the research community, incubators, accelerators, and so on. Yeah, our main activities is in supporting small, medium-sized enterprises, for instance, in partner matchmakings for research and development activities and for discovering new market opportunities, enhancing the visibility on international level, discussing innovative topics through ERCI task forces. I have some examples on that, and providing networking opportunities, webinars, workshops, networking events, fairs, business trips. And our yearly highlight are the ERCI Innovation Awards. Yeah, coming to the task forces, very active at the moment is the multimodal and logistics task force with 2 activities. There is one on military mobility and the other on intermodality. There is an activity took place in February this year in La Spezia in Italy to discuss how to react on the current situation, how fit is the railway system or the intermodal system to ensure military movement, and so on. Further steps are planned. Some details you can find about this initiative at our ERCI website. The other activity will follow in 3 weeks. There will be a webinar on intermodality, especially transparent multimodal rail supply chain powered by GS1. If you do not know what GS1 is, it is a non-profit international organization that develops and maintains standards for barcodes and other identification systems, was founded in 1974 and is headquartered in Brussels. GS1 standards are widely used across industries to improve efficiency, safety, and transparency in supply chains. One of its most well-known contributions is the barcode, which revolutionized retail and logistics by enabling products to be scanned electronically. GS1 also works on RFID technology, product data synchronization, and next-generation barcodes to bridge the physical and digital worlds. So registration is already possible. All links you will find also in our chat. For sure, we have several contact opportunities where you have the possibility to get in contact to us. Leads me to the first presentation, and the moderator of the first presentation will be my colleague Rico from the Rail S cluster in Saxony, Germany. Rico.
Thank you, Lutz. Welcome to everyone to today's webinar. I would like to introduce our first speaker. Peter Berger has over 25 years of experience in geotechnical and geotech measurement technology, data acquisition and instrumentation. As Director of Sales at Senceive, the UK-based leader in wireless remote condition monitoring solutions, Peter is responsible for driving business development and sales across Europe, Asia, the Middle East and Africa. He defines growth strategies, leads go-to-market initiatives, and implements innovative sales and revenue models in collaboration with partners and distributors. Peter, the floor is yours.
So thank you, Rico. I will share my screen. I hope you can see my presentation. Just a minute. Good, 25 minutes. Thank you very much, Rico, for the introduction. Yeah, we will talk today about remote monitoring technology for rockfall and slope stability. First, we will have a quick look at Senceive, our company, the technology we are offering. Then we will quickly define what are geohazards, what do we understand, what are geohazards, and how is the risk for the railway infrastructure. Then look at the growing threat and the growing costs of geohazards for railway infrastructure. And then we have a look at what solution we can offer to address these problems with wireless remote condition monitoring. And then when there's still time, I have also some case studies, and then we have time for questions and answers at the end. When we look at Senceive, Senceive is a UK business. Our headquarters in Milton Keynes. We have been founded 20 years ago as a spin-off of UCL. And since that time, we have become the leading manufacturer of wireless remote condition monitoring solutions. So our customers have installed more than 100,000 sensors on transport infrastructure, other critical assets, and we have now global coverage, provide local teams in the different areas, provide 24-hour support, and provide solutions for surface, subsurface, and structural monitoring, and also provide smart tools like InfraGuard, where we will have a closer look later today. And we are part of a Canadian technology company, Privian, that has bought us a couple of years ago. What is key when we look at what we are offering? This is sensor and communication technology. And when it comes to choosing the right communication platform, it is important to know what you want. Basically, if you want a dense network of sensors, if you want high frequency reporting, if you want to integrate multiple sensors into one network, if you want to have fully remote installations by powering your communication gateway by solar power, then, or also use network intelligence, then our flat mesh solution that is based on the 2.4 gigahertz frequency is the right choice. It comes with these functionalities that I have mentioned, but is limited to a certain number of nodes per gateway and also can only cover a certain range, so up to 300 meters. But it comes with the advantage of a mesh network where the data hops from node to node, and if one node fails, the network is self-healing. And this allows us to provide very reliable communication networks that are key to monitor critical infrastructure. But there's also another option if you want to cover a larger area like a city or an open pit mining site where you want to integrate to one gateway more sensors, want to cover areas up to 15 kilometers. Then we also have a communication technology based on the LoRaWAN frequency that we call GeoWAN. But this comes with some limitations regarding reporting rate and also network intelligence is not available. Yeah, most of our time today we will talk about our focus on movement monitoring and tilt sensors, but this slide shows our whole railway monitoring offering. So we provide different kinds of sensors, mainly tilt sensors that can be installed on the railway sleepers to monitor track geometry parameters, can be installed to tunnel portals, retaining structures inside tunnels, to monitor the structural integrity, or you can integrate geotechnical sensors like track sensors, piezometers in the ground, load cells, if required, all in the same communication network. And what we will focus on today is monitoring embankments, shallow slope failures, where the tilt sensor is used to detect these movements, and in combination with the camera can allow you then to do a visual inspection on site and decide if it's still safe to operate your railway line. But just before we look into the technical details, what are geohazards? So there's a definition, of course, that you can find also in the literature, but it's basically a natural or human-induced geological condition or phenomena that poses risks to life infrastructure and environment. Examples can be rockfalls, landslides, earthquakes, volcanic activity, or soil erosion. This can be influenced by climate change or by human contributions. We see here an example of a rockfall event from 2024 in this red panoramic road in Austria, where a big rockfall event damaged the road. In the past, it was safe to, or these events were not so common, but because of the influence of climate change and to some extent human contributions, these things get more common. What are the throwing threats and costs of these geohazards that we have just seen? When we look at Senceive's home market, the UK, and Network Rail as the railway operator or the owner of the asset, Network Rail has inherited or manages 190,000 earthworks assets. These are comprising of soil cuttings, embankments, rock cuttings, showing or having different risks and different, let's say, specific things to consider. When we look at the map on the right side, where we see all these red dots, just in the last 20 years, Network Rail has reported nearly 2,000 earthworks failures. Failures that have caused the blocking of the track, have caused to stop the train, or worst case, have also caused a potential derailment. And Network Rail has also provided a very comprehensive report to understand this growing risk, and they found out that over the last 20 years, the heavy rain events have increased significantly, that the number of wet winters, so these events mainly happen during the rainy season, there are more wet winters, only 4 wet winters in the last 20 years. That was not the case in the past. And this leads then to a significant spending in repairing these earthworks and do maintenance works, and of course do monitoring. And currently we are in the CP7 maintenance period with Network Rail, where they will just spend 4.4 billion pound over the next 5 years, just for these operational activities to keep the assets safe, to maintain them, to repair them, and also, of course, invest in monitoring. But not only in the UK, when we look at my home country, Austria, also in 2024, we had massive rain events in September, where we saw more than 300 millimeter of rains just within a very short time frame. And we had rain events that were where we had in one day more than normally in a whole month, and this caused then also a big disruption of the railway line in the eastern part of Austria. The very important connection between Vienna and Salzburg, the Westbahnstrecke, was blocked, and they had to repair. The tunnels were flooded. We had earthwork failures, blocking of the track, and they had to repair that, and now it's again, the track has been closed again, and the investments and the damages were more than 100 million euro just by one event last year. But when we look at how we can address these geohazards and with wireless remote condition monitoring, well, we have heard or we have seen in the last slides that globally extreme weather events have been more common. When we just look at last year, we had a record-breaking year of heat and rainfall. And of course, these consequences are increased number of landslides and rockfall events that interfere with our infrastructure. And having an early warning system in place is crucial. And we have what I will present now is an early warning system that addresses these surface slides, these shallow slope failures and rockfall events, and how we can potentially help to mitigate the risk. The key to that is network intelligence, and we call our solution InfraGuard, that leverages the flat mesh network and some edge computing functionality that allows us to do sudden movement detection. So basically, a sensor normally takes a reading at a predefined interval, let's say every half an hour, and our tilt sensors can do that then without maintenance for more than 10 years. But if something is happening outside this routine or report scheduling, this is key to detect the events that happen during that period. And therefore, we have developed a system that we call InfraGuard, where a tilt sensor is installed on a stake that is installed on the slope. And if between these scheduled readings, a sudden event is happening, basically acceleration that causes a rotational movement, the sensor wake up and start to do some smart things. One of the smart things is then expediting alarms. So basically that means that the node immediately is waking up, is taking a reading, is sending the data to a gateway via the cellular network to a server, and an alarm is immediately sent out so that you're already alerted that something is happening. So basically, you don't have to wait, for example, half an hour, you will get an information immediately. Then the other smart thing is dynamic reporting. So normally, as I said, you would take a reading every hour, but as soon as there is something happening, using predefined thresholds, you can increase the reporting rate automatically. So if the sensor starts to detect something, it will automatically take readings in a higher frequency, send data out regularly to understand if it's a real alarm or not, and will also basically, you see here the different alert thresholds and what is happening, that you basically increase the reporting rate if a certain alert threshold is hit. We have at the standard time less risk, less data. If you have higher risk, of course, more data is sent and more readings are taken. But the other smart thing is that you're triggering also other alarms. So this helps us to understand, is just one sensor showing an anomalous reading, or is it a genuine alarm? Yeah, so it wakes up then other sensors. They also take readings, and if it's just not at a single location, if also other sensors start to show this trend, then it's a real alarm, and then an image is triggered, alarms are sent out, and the people in the signaling or in the control room can then take a qualified decision. Yeah, and this solution, this InfraGuard solution, consists of this software and this network intelligence, but also of hardware components. In this case, the tilt meters that come with very long battery life and are installed on these stakes. And also an integral part is a camera that gives you high quality images that are triggered by the movement of the sensor, or you can trigger it manually to do immediate visual inspection from your control room and decide what you need to do. So this sudden movement detection is key for our technology, and here you see some examples how this looks like. These are some earthwork sites where sensors have been deployed. You see here that slope failure starts. There's a potential risk that it will block the track. And we also, in our R&D department, to do some smart things with these camera images to understand also if to use potentially photo monitoring to get a wider information of the area where the slope failure happens, not only at the single point where the sensor is installed, but also to use these images that we have in a high quantity. If you consider in the UK alone, we have 60 kilometers of slopes that we have installed with the help of Network Rail, where we have more than 2,000 or 1,800 cameras installed. And with this data, you can do a lot of smart things. And I have here a little video that shows you the functionality of InfraGuard. So we see here a standard UK slope with tilt sensors installed with a camera close by. We have a standard UK weather. It is raining, but it starts to rain heavier. The pore water pressure, the saturation in the ground, water saturation in the ground increases. But the sensors take readings every half an hour because everything is stable. They all did a great job. But one sensor suddenly starts to identify a movement. It wakes up, it triggers immediately an image, it sends an alarm out, increases the reporting rate. And and you can already check, oh, something is going on. You have an early warning and you are alerted. You need to be sure, oh, I have to be careful. And then the real event happens. All the other sensors wake up, provide alarms. You get readings and a higher reporting rate. You get again an image, and you immediately can decide, oh, do I need to stop the train? Do I need to close the track? And this has been done several times, and these systems have avoided derailments, which are then always a very costly event. Here again, a summary. You see here the sudden movement. In this case, we detect tilt, the rotational movement. We will see with our rockfall solution that we also have a similar functionality for impact when it comes to rockfall. But key is sudden movement, network triggering, dynamic sampling, and then alarm escalation, integrating a camera and be able then to take a qualified decision. But we also, because UK has a lot of earthwork assets in Europe, in Central Europe, we have a lot of rockfall. We have developed also a system where we use our sensor technology, a combination of a potentiometric sensor with draw wire sensors that are installed along the cat fence together with a tilt sensor with InfraGuard functionality combined with a camera for visual inspection that then can be installed at these rock protection structures. And if there's an event, if a rockfall occurs, the alarm is triggered and you get also an information, is the rock protection net still okay, or do you need to send the maintenance crew out? Again, alarms are set out, InfraGuard functionality, in this case, impact is available, and you can also have then an image to validate what the situation on site is. Yeah. And we also have here a little video, but I think I need to remove the tone. So you see here different deployments of this rockfall solution. Can be also not only for rail infrastructure, roads, or also for housing, for villages. You see here the components. This is the potentiometric sensor with the draw wire sensors. On the top, you see the tilt sensors. You see here now that smaller rocks are falling down. The draw wire sensor there's an extension in the sensor. You get an alarm, you know, oh, the net is filling up. Then you have a larger event where then the tilt sensor detects the impact, can also then cause or trigger an image and send an alarm out. Or if you have a really large event where potentially the impact on the pole of the rock protection net is triggering the InfraGuard functionality. So basically small, medium-sized, large rocks, you normally have a solution for that. And we deploy these systems not only at road and rail infrastructure, but also at mining sites and also in areas in the mountains where potentially also villages or people are under threat. So I think I'm good in time. I'm just 15 minutes. So I have just a couple of slides of case studies to show the functionality. First, of course, as I said, we have 60 kilometers of embankment installed as part of this maintenance contract with Network Rail. And people might say, why do I need the camera? Yeah, visual inspection is important because then you can detect if something is blocking the track or what is happening on site, and you don't have to go there. And the key thing is that the camera needs to detect also during the night an object of the size of a football at a distance of 50 meters. This allows then the train the operator to decide if he needs to close the track or not. But it also does other things. Here you see a nice image from the daytime, but it not only detects slope failures, it also detects, in this case, a car that has hit, unfortunately, or was driving down the slope. So also the system can detect these things. It's not the main purpose, but you know what is going on site. If you would have just get this crazy alarm before you had 3 millimeter per meter movement, and suddenly you have, the pole is hit and you have a large rotational movement, you would say, oh, the system has a problem. This can never happen. But if you look at the camera, well, it was a car, not expected, but still a threat, and they had to stop the track and had to remove it. So this is the situation then in the morning. Network Rail did a great job to remove the car, and in the morning everything was fine again. Or another example from rockfall, this is at a location in Austria, south of Salzburg, at Lent, where we have a road and below a railway line, where they have installed a cat fence with 1,500 kilojoule design impact load, and there were tilt sensors installed on the poles with Austrian Railway. And the reason was because they know that there was a rockfall threat. They put this rockfall protection in place. The system was installed and worked properly. You see here an image from the morning, and then what does the system? We see here now that in the image on the right side, smaller rocks start to fall down. At 9:17, first alert was triggered, an image was taken. Normally only every 6 hours an image is taken, but now it is triggered. They could immediately look what is going on there. Yeah. Later at 10:12, the big rockfall event happened, and you see that the rock net filled up. It did its job. Yeah. It protected the asset, but you can check visually by using the camera how big is the threat. And of course, they were able to talk with the geologists and the maintenance team, they could send people out, fix that again. And that was exactly what the system should do. You see here also a time displacement graph. You see here the event, you see here what the event caused, and after removing the material, the system was set back baselined, and it's now working again. And since a couple of years, it's doing its job and provides reliable data and images from site. Good. I think I managed to stay in time, and yeah, I think it's now good time for questions and answers. Thank you very much.
Yeah, thank you. So we have several of questions and dear participants still has the possibility to ask questions, wrote in the chat or raise your hand and you can ask this directly. So yeah, now I will start with the first question. You mentioned InfraGuard several times. Can you explain how the systems improves early warning and response compared to traditional monitoring methods?
Yeah, as we have seen, these different functionalities, the key thing is that with the flat mesh technology, with the mesh network, the sensors would normally take readings every hour. If you have a LoRa system, the sensors only take readings every hour. They don't communicate to each other. If you have a total station monitoring system and geodetic monitoring system, you would also take readings every half an hour or every hour, but you don't know what is happening in between. But with the specific functionality of the tilt sensors having also an accelerometer inside, they take readings, they sleep then for 1 hour, but they are still listening. And if something is happening in between, you will get an alarm without latency. With a traditional system, you would have to wait until the next reading is taken, and then you would get an alarm. Yeah, but you would potentially lose half an hour, and during that period of time, a lot of trains can pass by and potentially would derail. But as there's no latency with the alarming, it gives the specific functionality that you get an alarm immediately. You don't have to wait for the next scheduled reporting time. Yeah.
Okay, thank you. Next question. In Land in Austria, the case study, how did the system respond to the event and what were the particular benefits for the asset owner?
Well, basically, we are at very remote locations, so these systems work only on solar power, so no mains power required. So if there are critical assets somewhere in the mountains, you would then need to, you would have to rely on visual inspection by the locomotive driver, yeah, or by people who see that event, yeah. If you have a system in place at critical areas, you would get immediately an alarm and immediate information. If it's a small event, if you have a traditional method and you will get an alarm, you still don't know the impact. Yeah, combining that with a camera allows you then to really decide, do I have to send the maintenance crew out immediately, or is it okay? It was a small event. The net is still has enough capacity to accommodate material, so they can also optimize their resources, because the maintenance crew would potentially be sent out without really having the need to do a lot of work. They would just check and go home again, and this they could do by the camera. They don't have to go there. Yeah.
Okay, thank you. And next question, with climate change intensifying geohazards, how do you see remote monitoring evolving in the next few years, especially for rockfall and landslide prone regions?
Well, I think as the danger for assets for life of people is increasing, I think the systems will be deployed in a larger scale. But when you have, let's say, like camera systems, there's a lot of progress in AI, how to do image correlation. There could be the use potentially, there are a lot of webcams out there. Potentially, if you go to a ski resort, you have the weather webcams. If you use standard cameras, yeah, and you would have a way to do AI image processing, and you would get already an information of a potential risk, yeah, out of systems that maybe not have been the main purpose to be a monitoring system, but understand, I can use these images to understand or create or identify areas of risk, map them, And then I could deploy these intelligent monitoring systems at the areas with the highest risk. Yeah. So I think it's a big effort by asset owners to map or provide a geohazard risk map about along their whole railway line or assets. But I think it's also to use existing things with AI technology to identify risks, and then it's also a question of money. We would love to install our sensors over 100 kilometers of track or railway asset, but in the end, you need to spend your money wisely and install the sensors where the biggest risk is happening or is there. Yeah, and I think you need other tools than to map that to get the first information and then really deploy the systems where it's most important. Yeah.
Thank you. Another question. Have you looked at first the added value of data and sensor fusion? So I would say we go step by step. So have you looked at the added value of data and sensor fusion?
Of course, there's, as I mentioned, you can do things with the information you get from different sensors, but of course there are other companies that provide smart solutions that do dynamic monitoring, that use geodetic methods to get absolute movement information. And I think all these things together give you then a full picture, and then there's a trend then to use this information, together with a 3D model of the structure to do predictive maintenance. I think it's not all. We don't tell the only truth. There are other things that also add to the overall picture. And I think bringing that together, using 3D models and predictive maintenance is important and will help the asset owner to manage their assets in a safe way, and efficient. Yeah.
Then also have you looked at vehicle running dynamics analysis and onboard sensors?
Well, we as a company, we are mainly providing sensors that are stored at the location, stay there for many years without maintenance. But we know that there are smart companies out there who have vehicle-based sensors that will give you, of course, information about the track geometry, if it's safe to operate. We are not looking into that, but the information that we get from these systems, so also if there's a train-based system that does scanning or uses high-resolution cameras, that I think is also important to use that information that you potentially get when you do anyway railway inspection of assets. Use this data that you already have to also qualify, identify, map the slopes and potentially earthworks assets, and use these systems to also for this mapping and identifying areas of significant risk. Yeah.
And then last part, have you looked on onboard condition monitoring of vehicle track dynamics interaction using machine learning?
This is a very, very interesting field. Yeah, of course, we're always looking into new technology. At the moment, we are really providing let's call it static monitoring at a certain location. But I think this could be something that would be interesting to explore and also cooperate with companies that are already using that. Machine learning, for sure, not only for that, but also, as I mentioned, when it comes to image correlation, photo monitoring, and predictive maintenance, I think all these different fields need to contribute to a holistic view on the risk of an asset. Yeah.
Okay, thank you. Are there any other questions, probably also direct to the speaker?
No question from the chat. Oh, there's one question. Which are your proposals when power supply is not available on site? How sensors are powered?
Basically, the only two devices that need some kind of power permanently is the gateway that is powered from a 20 or 40 watt solar panel, so no mains power required, and the camera is powered from a 45 watt to 80 watt solar panel. Both comes with a backup battery, so if there's for some reason no sun or they remove the solar panel, we saw in certain countries that these get stolen, then you have to replace it. But these devices are also monitored regarding their battery status. We would get an immediate alarm if there's no power provided. But the big advantage of the flat mesh solution is that you don't need mains power. Yeah? And the sensors, they come with a battery that has a high battery life. Yeah? So our sensors, when you run them on 15-minute reporting rate, they will last 10 years. We have deployed in the Netherlands 3,500 sensors with a partner that is a 1-minute reporting rate. Yeah. And they will still last for 5 years. And then, of course, you would need to replace the sensors or at least the battery in the sensors. But the communication is fully autonomous without, you don't need mains power on site. That's the big advantage.
Okay, thank you. Any other questions?
Seems not to be the case.
Seems not the case.
Yes.
Okay.
Sorry.
Thank you very much.
Yeah.
Can you hear me?
Yeah.
Yes, we can hear you.
Hey, Peter. This is Peter Melander in Stockholm. Thank you very much. Are you still classified as an SME, a small medium enterprise company, given your Canadian ownership?
Yes, because the Senceive entity is still an entity in the UK, and we still have 100 employees. Yeah, so that is still, as far as I know, that there is no restriction to that classification, because there are companies that as long as we operate and as an still independent company and not. I would say we still classify for that. I'm not an expert in classifying that, but so far we were told that we are. So. But that's not my expertise.
Okay. Excellent. Well, there may be some opportunities for innovation funding that could be the basis for joint demonstration projects.
Yeah, we are always open. We also have European entities. Yeah, so we also we try to cooperate with European companies. When you are a UK-based company, of course you still have access to European Union funding, but you're a little bit, let's say, outside there. But there are ways to cooperate, and we are open to do that, of course. Yeah.
Okay. Thank you very much. Thank you.
So there is also an important remark to say if you are an SME, what is your yearly turnover? Is it less than 50 million euros or over? And I think we have to we could discuss this afterwards. And then for sure this webinar is exactly the purpose is exactly in order to find good connections to good maybe funding opportunities for joint R&D projects. So you're kindly invited to take this opportunity to get direct in contact via these ERCI webinars. Very good example. Thank you. So coming to our next presentation, and this is Trevor Moore. And I have to say something about Trevor for sure in order to introduce him. Trevor is a chartered surveyor with CICES and has over 25 years experience within the survey and mapping sector. He has held various technical, operational and commercial roles with some of the largest surveying companies in the UK. Trevor, the floor is yours.
Thank you very much for the introduction. Let me just share my screen. That should come through now. Yeah. Perfect. Okay, great. So as Lutz has mentioned, my background's very much in surveying and mapping, and I have first-hand experience of the challenges around conventional track surveying methodology. So I used to, go out on track in the middle of the night. And working within very tight sort of schedules to try and complete surveys. So my purpose here today is to talk to you about those challenges and provide you with an overview of the RILA technology and the benefits that this can bring to projects and infrastructure managers. So firstly, a little bit about Fugro, which is the company that I work for. It was established in the Netherlands in 1962, and we now operate in over 52 different countries with over 11,000 employees and a turnover of around 2 billion per year. So we work across three main verticals of energy, infrastructure, and water. And our focus really is around the capture of geospatial data of the Earth. So we capture information above and below the Earth's surface, and on land and in the sea. So we pretty much cover every part of the Earth's surface. And we offer services relating to mapping, monitoring, geophysics, site characterization, Earth observation, and consulting, offering an end-to-end solution from planning and design through to decommissioning. And Fugro's focus is very much around capturing information remotely. So we've developed autonomous vehicles that go around the sea to capture the seabed levels. We have remote sensing via helicopters. We have our RILA system, which is a train-mounted sensor, which I'll talk to you about. So, we really focus on innovation and a focus on geodata. So these challenges that I was talking about, conventionally to go and do track surveys to pick up accurate information for design, this you normally need track access. So my focus is primarily in the UK, where we have a very high frequency of trains. So usually track access is arranged during midweek nights or weekend possessions, also probably at night. So these are very short in duration. It takes time to organize. It's logistically difficult. And also we need additional safety staff as well. So you have more people on site to complete the surveys. There's also a requirement for survey control. So anybody who's has a surveying background or knowledge of surveying, the survey control network is the backbone of any surveying activity. So, and the coordinate systems and that type of thing. So that's normally done as a separate exercise, which means that you need more time to go out and track and install it and coordinate those survey control points, which are used as the foundation of all subsequent surveying activities. So from a health and safety perspective, again, working at night on uneven ground with ballast, that provides or poses a risk to health and safety of workers. You've also got, where they work very long shifts during possessions and traveling to and from site afterwards. So again, that's been an issue in the past with, working time directives put in place to try and minimize fatigue of track workers. We've got extended delivery times. So because it takes a long time to plan access to the track, and normally to get, larger surveys completed, you require multiple possessions. So this could take weeks and even months to complete larger surveys. So extending delivery times and extending the project timescales as well. And then finally, we have increased carbon emissions. So we've got multiple teams traveling to the site every weekend. There may be plant and equipment that might be used on the site for, task lighting, that type of thing, all which increase to the overall carbon emissions of a particular project. So what's the alternative? So we have what we call our RILA system. It is a train-mounted sensor. Just to give you a quick overview, we have a GNSS sensor, which picks up the absolute positional accuracy of the unit and the resulting data. That works together with an IMU, which is an inertial measurement unit, which is a very high accuracy sensor that picks up all the slight movements. It's got accelerometers and gyroscopic sensors within the sensor. It works together with the GNS receiver to then provide very high accuracy information. We have a 360-degree scanner, which works in a profile that captures the railway environment as the train moves down the track, and that scanner is used to provide gauging information, but also provide the three-dimensional point cloud data that we capture, which can be used for a variety of use cases. And finally, we have our railhead profile scanners, which we call the rail stripers. This projects a laser scanner onto the railhead, which enables us to accurately determine the cant and gauge of the track, as well as the rail profile. So we can actually measure the height of the rail. We can measure the rail wear as well. And then we also have 3 forward-facing cameras. So that gives us the visual data that we need, and that can be used for, again, understanding the track environment and helping us determine or utilize the point cloud data. So the product itself has Network Rail approval. Network Rail has actually written or created a specific accuracy band within their specifications for us, which they call Band 1A, which enables us to provide accuracy, or certified to provide accuracy to an absolute position. So in real world coordinates, the true position to plus or minus 8 millimeters in plan and 12 millimeters in the vertical. So but we also, in terms of relative accuracy, so relative from the track itself, we can provide the data to an accuracy of 5 millimeter. And we are also approved for gauging within the UK as well, so we can provide data directly into the National Gauging Database. So we've been operational since 2009 in the Netherlands and 2013 in the UK. And from the map, you will see, we've deployed at scale within the UK, Netherlands, Denmark, Germany, and selected parts in other parts of Europe, selected projects in other parts of Europe, and Australia and America. So this little video here basically shows how the unit is attached to the front of the train. You can see he's attaching the coupler adapter. So we have various different adapters that can be used to suit various different coupler types. We also have a buffer adapter. So if we want to attach the unit to an MPV or other rail vehicles, we can do that as well. So the unit then is attached to the front onto the adapter, and then we raise the mast to then capture the information. We are currently working on developing a shorter mast so that the mast sits just above the unit. It's never really been a problem because the mast doesn't really obscure the driver's vision that much, and it's the main reason we're doing that is that we have to turn the unit on when it's on the side of the platform, and then when basically we move it onto the train, once the sensors, the GPS signals moved up, it basically feels like the unit itself feels like it's swapped hemispheres, basically, because it's turned from upside down to up, and it really messes with the processing. So it's just going to make it a lot easier for us, and the data will be cleaner, helps with the localization, that type of thing. So in terms of our position in the market, we can serve various different customer groups. For geodetic surveys, that's normally carried out by track trolley surveys, or total stations, that type of thing, or static laser scanners. RILA provides an alternative to that without having to access the track. In terms of inspection and monitoring, so asset condition, we get the absolute track position, but we also get the relative information and the track geometry as well. That's normally captured by your measurement trains or by visual inspection. So we can service that customer group as well, and also asset mapping. So mobile mapping. Normally, you can get a mobile mapping unit that is attached to a specific vehicle. Again, we can service that market, but the fact is that we use in-service trains, which means that we minimize the impact on the rail environment. So a little bit more about RILA and its benefits. So we don't need track access. So it's far safer. We are able to mobilize far quicker because we don't need to wait for track access. We simply position the unit on the front of a train at a terminal station, and we can capture rapid amounts of data and rapid capture over extensive distances in a day. So the unit operates at up to 125 miles per hour. So you can imagine the amount of data that we can capture in a day. It can be fitted to a wide variety of rail vehicles in under 2 minutes. It's a standalone unit. So it doesn't need any power from the cab or the train system, which means that it's we don't infringe on any other operating systems, and we use in-service trains, so we removes any dedicated access costs and disruption to planned access. And because we are using an in-service train, it means that we're minimizing the carbon footprint that would normally be associated with return visits to capture the survey information. So based on RILA and using a conventional surveying methodology, this is based on a project of 12 kilometers long. We've calculated around a 26% cost saving. We have an 85% reduction in site works from 11 down to 1, and we've got a 99% removal of boots from the ballast. So essentially, the only time we have to go on the track is when we're mounting mounting the system and then taking it off the train. So really a big increase in safety. And RILA provides significant benefits in terms of cost reduction and program for track sections exceeding 5 kilometers in length. So that's our kind of sweet spot. If it's smaller, then it's probably going to be more cost effective just using a track trolley or a conventional surveying approach. But obviously, once the survey length increases by over 5 kilometers, then there's exponential savings. So some of you may have seen this pyramid before in terms of the data pyramid. So we've got data at the bottom, which is essentially when we capture information. We take that information, then process it. Take the data, process it into information. We use the information then to understand and get knowledge, and then get wisdom. So getting insight to help us make strategic decisions. So how that applies to RILA, we do our data capture from our train. We process the information, so all the different sensor information we combine, and we have various different algorithms that allows us to then produce our 3 sort of core data products. So we have the absolute track position, so that can help us manage the managed track position, so understanding if there's track movements as well over time. We have the matched point cloud, which is our core data product, which we can use for various different use cases. And we have the geoposition videos. Those are 3 sort of main data outputs that we have. And then we can use that to then produce our information products. So we can use it for structure gauging. So we can either show the information within our portal. So we have or we can produce an SC0 file, which is the format in the UK, which will then go into the RGDS database, which is the railway gauging data solution. We can do third rail mapping and gauging, so understanding if the rail is too high or too low, so that would affect the contact with the third rail, which again affects the wear, and also if it's sometimes people don't know where the rail changes sides, so we can map all of that very accurately as well. We can do topographic extraction and as-built surveys. So again, for using that for design, ballast profiling, understanding where we can move ballast from one area to another, asset mapping. We can understand vegetation encroachment, relative track geometry. We can use the geoposition video together with the scan data and our absolute track position to do signal sighting. And then we also have a smart tamp solution, which allows us to get the real absolute accuracy of the track and do an optimized tamp through a larger section of track. So sometimes they do, tamping at a smaller intervals, just so over a certain chord. So being able to tamp over a longer distance gives much better information in terms of the accuracy. And then finally, we have visualization of that data. So we have our RailData portal, which I'll come and show you in a minute. So essentially, we can collect the data once and use many times. So, as I mentioned about the gauging, we get height and stagger information for ENP, we could the conductor rail monitoring. There's various different use cases that it can be used for. So we have also various different sensors. We've got our helicopter-based solution, which provides aerial LiDAR. So if you want to map a wider corridor, we can combine the aerial LiDAR with our RILA data as well to actually improve the overall accuracy of that information. And we also have a train-mounted GPR sensor. So if you want to understand below the track bed and the various geotechnical information of the track as well. So from our data, we can produce models and CAD outputs again for design, whatever is needed. There's multiple uses of that data. So just looking at our rail portal, this is where we can visualize the data as well. We've got you can click into the portal, and it allows you to then visualize what's on the track. So it's a GIS-based system, so we can also change the functionality of this as well. We can use it as a download tool to deliver information. So we've got our imagery and we've got our scan data all in one portal. We can we can move backwards and forwards along the track as needed. And then also we can change the transparency basically of the imagery. So that allows us to overlay the scan data and the imagery, which helps us a little bit with the interpretation of the data. So within these little blue dots along the track, we can pick up information. So that's our absolute track position. We know the coordinates. We know the chainage. It tells us which engineer's line references. But we can also download the data as well. So this is like a height and stagger form, which is in the network rail format that allows us to so we can pick up lots of different information. This is just another quick video of this is where we've used the portal to show third rail mapping. You can see we can again download information and get track geometry, track center lines. All of the information is translatable, so we can export that out into different formats. But also you can see by the colored nodes along the track, we can set different parameters around the track to tell us immediately where something is in tolerance or out of tolerance. So that might be where the conductor rail is a little bit too low or it's a little bit too high. So a very easy way to help us visualize exactly what's happening with that track. So finally, just to recap on the key benefits. So safety is the #1 priority. So removing boots from the ballast, stopping these manual survey activities, and eliminating site visits helps us improve safety. We've got efficiency. So we use in-service trains, so it's reduction in access costs, less disruption, and contributes to carbon reduction. We have accuracy and repeatability. So our system, we do multiple runs along the track, which allows us to average the data. And we have very smart algorithms that basically help us match the track strings together to get the best optimized accuracy. And this is repeatable and to that band 1A accuracy. As I said before, there's multiple use cases that can be used for maintenance, asset management, and operational use cases, all from the same data set. We've got our RailData platform, which is pretty much ready to go, and we can supply data into your own systems as well. And we're approved by Network Rail for gauging as well. So that concludes my presentation. Thank you very much. My contact details are there, and I guess we'll hand over to some questions now.
Yeah, indeed. Thank you, Trevor, for your presentation. I just prepared the slide of questions, and there are many questions. The first one, how do you overcome any loss of signal in areas with poor GNSS, such as tunnels and urban canyons?
So generally, the IMU, so the inertial measurement unit, because it's how these sensors work, the faster we travel, the better they actually operate. So they need a lot of energy within the system, which allows it to then to help minimize the drift that you get with an inertial measurement unit. So when we lose signal within a tunnel, we can normally travel, quite a long distance before the system starts to drift. But because we do multiple runs and we can average it, we have certain algorithms that can help us ensure that we get accuracy. So there is a loss of accuracy in tunnels, but the relative accuracy remains the same at 5 millimeters. But we can generally, even in GNSS denied areas, we can still get the accuracy down to within 100 millimeters. That's the sort of maximum that we lose. But we are working on we're implementing a new bit of we're making a massive investment in terms of our hardware, our processing algorithms, and the platform that will actually allow us to use various other sensors and capabilities so that we can improve the accuracy in tunnels.
Yeah, second question, what makes RILA different from other train-mounted sensors capturing data?
Primarily, it's around the absolute track position. So even measurement trains, most of them work on relative accuracy, but understanding exactly where the track position is, that's the reason why we can use it for design, and particularly the accuracy around the rail. So there may be other mobile mapping systems, they capture the environment, but they don't get the accuracy that we can. And for instance, mobile mapping systems are not approved for use on Network Rail because they can't provide the accuracy and the gauging that we can provide.
Yeah, the next question you already know from Peter. It's nearly the same one. Have you looked at the added value of data and sensor fusion? First part.
Yes, I mean absolutely. I think our system incorporates lots of different sensors, so we do try and improve that. We can augment our sensors and deliverables with other information. So, we're looking at where we look at the design position of the track and our measured position of the track, and then we use that to do our smart tamping solution. So it's the more information we can add on to that, we can provide.
Yeah, have you looked at the vehicle running dynamic analysis and onboard sensors, maybe connected with the question after that? That was in addition to that question.
Yeah, I mean, vehicle dynamic analysis and onboard condition monitoring. I think we do measure the track geometry, and we are looking at different machine learning algorithms to help us with smart sectioning and such like. I mean, our use case is primarily around understanding the track geometry and the track environment. I think there's obviously other specific products like a measurement train that will be looking more at those sort of, dynamic interactions with vehicle and track. So those, we want to be laser focused on improving what we do as specifically, but obviously there is other products and technologies that are already doing other things. So it's we can try and combine these systems, and it is something that we look at, but it's just trying to find this specific use case for it.
Yeah. What about coming to the next question, because it's directly connected to that. The vehicle running dynamics onboard sensors are existing on many trains as a connected fusion. Is it complement to RILA 3.0?
Yes. So, for instance, one of the sort of use cases that we have is the fact that we can pick up the overhead line equipment and doing the height and staggers, but within a static position. So sometimes the catenary is measured in a dynamic, sort of under load with the train sensor. So we can combine that data with our data, but we can also look at the design information. So you've got three different parameters to sort of compare against. So it's that's probably an important understanding and a good example of how we can combine those different data sets.
Have you looked at the onboard condition monitoring of vehicle track dynamic interaction using machine learning?
So I think that was
the third
probably
part of the question.
just answered that question, I think. We haven't so much used. I mean, we've looked at machine learning for different elements, but not for vehicle track dynamic interaction.
How much manual effort is required to get all the measurements, especially in switch areas, for example?
So our solution is focused on remote capture. So we can get all the different information, but we have to monitor or identify the correct train paths so that we're going over all the required sections. So in S&C areas that we need to be more careful about how we plan the movements to ensure that we get everything. But our focus is getting all of the information from our RILA unit. There is instances sometimes where there's a passing loop or other areas which aren't necessarily where we could use manual methods to complement it, but obviously these are very discrete areas, and the benefit of being able to capture vast amounts of track sections in one go is still a benefit.
Yeah, next one. Any experience with RILA on urban tramway networks mounted on tram vehicles?
Yes, we have done metros. We have done trams as well. Trams generally, we don't see a lot of interest, shall we say, but we have done tram networks, and we've done metros as well.
Yeah, seems to be that Siemens Mobility is providing also a similar solution for tramways, looking into the chat, and maybe a joint collaboration could take place there. Where are treated the captured data? Next one.
So, not understanding the question. Sorry, what do you mean by treated? That where is it stored, or?
Yeah, I only copied and pasted the question from the chat. That is my issue. So maybe we could just proceed with the following one: how the data are transmitted from sensors to the central storage unit.
So all the data is stored on board the unit itself. So we have an operator that sits inside the train, which is connected, and he monitors the unit via a Wi-Fi link. But the data all stays on the unit, and then we take the data and then post-process it to get the output. So we are looking at providing a real-time link using 5G for the telemetry data, so that we can have a much more better understanding of the quality of the data that's being captured in real time. But at the moment, we capture the data and then we post-process it.
Yeah, I guess looking at the chat, I saw that the both last questions here were one question from one participant, and maybe your answer to the last question also answered the question before, but it was not the last question. I have already still have 3 questions, which is the hourly quantity of data you are collecting, which is the frequency of images.
So the hourly quantity, it's hard to quantify, but we basically can do a route-wide survey. We can, as I said, the train travels can travel up to 125 miles an hour. So we capture terabytes of data per day. So it's a huge amount of information, which we need to then process, which we process in the cloud. In terms of the frequency of images, it's actually video images that we capture. So for the forward-facing cameras, the rail stripers operate at 500 times a second. And the rotating laser captures 1.2 million points a second. So very, very high density of data. Obviously, if we're traveling at 125 miles an hour, we have to capture information, a lot of information. And then even at that speed, we do have some gaps, which is why we do multiple runs. So when we're overlapping the data sets, then it increases the density of the data set as well.
So, next question is asset condition monitoring data integrated into your RILA system. Is this data real time?
No, it's not real time. We would have to do the comparison afterwards. It's not real time. So that's probably where the measurement trains, the infrastructure fleets that constantly measure track geometry and that type of thing. That is probably better suited for that type of application. But we can do post analysis of the condition in the office environment.
Yeah. Then that is not the last one, but the question before. Can you select data related only to the trackside signaling equipment?
Yes. So we basically the data set that we captures everything within the line of sight of the profile scanner. So as we are moving down the track, we capture everything from your overhead line equipment, signaling, lock boxes. We capture everything within the line of sight of that equipment. So that's why we're able to use that to then create 3-dimensional models or 2D CAD or 2D or 3D topographic plans.
Yeah, I'm not sure that it was a remark or a question because I missed the question mark. One remark, as far as I know, that's not a device you mount on trains on standard operation. So you have dedicated measurement campaigns. Maybe that could be a question.
So the unit itself is designed to go on in-service train, and that's our sweet spot. So you will have seen in the video that I showed, you know, the unit is mounted on in-service trains, and we have done that. We've done it in Scotland. We've done it in, you know, extensively in the UK, Netherlands as well. We use in-service trains. It's not a dedicated train. So it's I think maybe just reading that question again, it's not something that we leave on the train all the time. It's something that we would go and do a specific campaign, yes. And if for track monitoring, in terms of track ensuring that the track is safe to operate, you have the measurement trains, and they will continuously measure the track. But this is a slightly different use case that we have. So I hope that answers that question.
So thank you very much. I will not ask for further questions because we have lots of questions regarding your presentation and also to the presentation of Peter. Thank you to both of you for these very interesting insights, and not to overrun your presentation time. That is very fruitful. So we can use the remaining time to provide you with some interesting information on ongoing activities, events, funding opportunities, and projects where ERCI is dealing with. So first, I want to ask all the participants to give us our short feedback. We have a short feedback questionnaire with 6 very short questions, including your ideas for future ERCI webinars, and maybe you are interested by yourself to present your innovative solution in one of our next ERCI webinars. Please let us know. The link is already in the chat. So normally we are recording all of the webinars, also this webinar, and for sure we have to cut the recording, and the cut recording you will find in some days at the YouTube channel of the former STARS project. So then the next ERCI webinars, we have 2 in our schedule. The first one is on transparent multimodal rail supply chain powered by GS1. This will take place not in 4 weeks, but already in 3 weeks on the 4th of June. You can already register, and there is a forecast on the webinar after this webinar. Is only 1 week later, on the 11th June. The topic is condition-based monitoring of rolling stock. So events. We have some certain events to present, and I already mentioned the yearly ERCI Innovation Awards. Some of the regions of our ERCI clusters are still having their regional or national contests. Some regions have already their deadline. As a result of the regional pre-selections, up to 3 applications per ERCI cluster could be nominated for the European stage. That means a maximum 54. And we are for sure very excited on who will be the best SME, the best large enterprise, and the coup de cœur prize for this year. And the awarding ceremony will take place at Expo Ferroviaria in Milano on 30th September this year. Yeah, some other activities. Next week is a very busy week for ERCI. We will be present at the railway interchange in Indianapolis with a booth. We are also have an ERCI delegation with 7 or 8 companies with us, and with a very interesting program. but we are planning also to go to Canada, mainly to the Quebec region, from the 8th to 12th September this year. The agenda is in preparation. Some points are already confirmed. Further informations are available on the ERCI website, and for sure you can take the opportunity to join this delegation. Another opportunity will be in Berlin, the Nice Railway Forum. That is the leading supplier summit in Europe in the beginning of September this year. And we have special conditions for exhibitors in the so-called ERCI village, e.g. a 4 square meter booth, including one Congress ticket for 1,800 euros per person. You can directly get in contact to the organizer IPM of this event to ask also some questions if you have, and for sure the possibility to book such a booth. And for sure you will meet other companies from ERCI clusters, and we will have a great time in Berlin. So some other events with the presence of ERCI. One of that is the Rail Life in Long Marston in mid of June. Then a second one nearly the same dates, the Eurasia Rail International Rolling Stock Infrastructure and Logistics Exhibition in Istanbul. And by the end of June we have the CIFER in Lille. You find details on all three events at the ERCI webpage on the category of events. Then, we are not at the end. There will be a speed match international B2B matchmaking event, a virtual one. It is organized by our ERCI partner, Eskişehir Chamber of Industry, and there will be a B2B matchmaking platform, and you can register there. The key points are the focus is on aviation, rail systems, and the automotive supplier industry. Yeah, next highlight is the ERCI or the acceleration event on AI organized by DTEC Fair in collaboration with the European Digital Innovation Hub AI Master in Italy. That will take place in Calambrone near Pisa, beginning of June, 4th, 5th, and 6th of June. It is on artificial intelligence, made easy for the railway and mobility value chain. If you are interested, you could pre-register for this event by following this link. So funding opportunities, 2 slides on that. There is still ongoing calls from the European Space Agency, the one on space for intermodal transport, the second one on space for rail. If you are interested, look at these information, and you can also contact us in order to find good partners for one or both calls. Then Horizon Europe, the working programs 2025 for several clusters, e.g. also for the climate, energy and mobility clusters are pre-published by the European Commission. You will find these information by following the next link. All the links are in the chat. So please also after this webinar, you have the opportunity to follow the chat and test all the links. Yeah, some projects, and for the projects, it's my pleasure first to hand over to my colleague Guido Ancarani from DTEC Fair. And DTEC Fair is a very active cluster in preparing and proceeding projects on European level, and we are starting with LEADER 2030.
Yes, thank you, Lutz. You have already put in the chat the link to this flagship project for ERCI, where we are coordinators as ERCI, having also other partners, which are JKZ in Freiberg, RailData, the Technical Center in France, and Technopark Istanbul. The aim of this project is planning for European autonomy to deliver Europe's rail in 2030, so it means for tomorrow. What are we looking at are the resilience of European supply chain for raw material and components that will be needed to supply and to deliver and to deliver the project which are behind the research and development project of Europe's rail. Next slide, please.
Yes.
Okay. So the next project is the project Idealist, which is a project covering free industrial ecosystem, also mobility, transport, and mobility and automotive. And here we have 14 partners. The project is coordinated by SIM in France, and DataQuery is one of the members. And what is interesting in this project are maybe next slide, the activities that we are doing. The first one is an hack and match, which is already the second one. This hack and match, like an hackathon, is this time is focused on AI for the digital and physical world. We have already collected 10 challenges with a call for challenges, and we are in the middle of the call for solution. So thanks to the link, you can see the 10 challenges, and therefore, if you are a solution provider, because you are a tech-savvy in this domain of AI, you can propose a solution. In this way, then we will put together the challenger and the solution provider, and at the end, in the mid of June, we will have the real hack and match, where the two parties can meet together and try to find solution to the challenge which is on the table. Next slide. Another European project is eBoost, which is related to electromobility for the recovery and internationalization of small enterprises, so electromobility. Here we have 6 partners, and again, DataQuery is one of the partners. You can follow the link for the project news. Next slide. I would like just to underline several events that will occur before the end of the month. The first one is a webinar on smart automation, for how to leverage AI and automation tool to boost communication, staff recruiting, and fares management. 15th of May. Next slide. The second is an event with the European Digital Innovation Hub, which are key pillars for digital transformation of SME. So this will occur on the 16th of May. Next slide. Third event is again an event with a European Digital Innovation Hub, about digital and intelligent green transformation in key sectors. We will have the Italian ADA, European Digital Innovation Hub, which is iMagister, in this event, explaining what they are doing for the companies. This will occur on the 20th of May. Then last one is 26 and 27 of May, an international business forum, which is organized by eBoost, and this will occur online. Next slide.
Yeah,
Back to you. Thank you,
yeah,
Lars.
thank you, Guido. We are on time, nearly on time. Just to repeat that the next ERCI webinar is on transparent multimodal rail supply chain powered by GS1, EPCIS 2.0 on the 4th of June. In 3 weeks, the registration is already open. You are warmly invited to contribute. And yeah, just to remember that we have a short feedback questionnaire in gathering your feedback for this webinar and to learn about your topics, your possible willingness to present at one of the next ERCI webinars. You are kindly invited to do so. And that is the end of this webinar. Thank you very much for your attendance, for your intelligent questions. Thank you, presenters, for the very interesting presentations. And see you soon. Have a nice day. Goodbye.